Whether you are discussing pitch changes with other musicians, or while looking at a piece of sheet music, you want to hear that music in your mind as you read it, or making observations about the various relationships that occur between musical tones, you are going to need descriptive terms that will allow you to both visually see and mentally hear those tones. The basic unit of harmony is the interval. The word interval, as it is used in music, describes the visual relationship between any two written notes and the auditory relationship between the tones represented by those two notes. Think back for a moment to the basic C major scale. There are a few things about the look and sound of this scale that come to mind just from viewing its notes. We can, for example, remember the individual name of the notes of the scale. We can identify the scale degree to which each of those notes correspond. We can recognize by the pattern of whole steps and half steps occurring between the notes that this is indeed a major scale. And we can, by now, readily bring to mind the tone pattern associated with a major scale. We can also recognize the look and sound of a whole step, and the look and sound of a half step. Learning intervals involves mastering those same concepts and skills, being able to recognize the look of any combination of two notes, as well as the sound that is produced by them. Intervals are made up of two elements: the visual distance between any two written notes and the unique quality of tone that those two notes represent. Intervals can be harmonic in that the two notes are played simultaneously or together, or they can be melodic, meaning that the two notes are played consecutively or one after another. The visual distance between two notes is described numerically as shown in the illustration. The units by which we measure the distance are the number of lines and spaces between the two notes. The quality of sound that occurs between the two notes is described by one of 5 terms: major, minor, perfect, augmented, or diminished. The distance between and tonal quality of a melodic interval is the same whether the pitch goes from low to high or high to low. For example, the distance and tonal quality of a C natural going up to a G natural is the same as that of a G natural going down to a C natural. Both are referred to as a perfect fifth. The first diatonic interval is called a unison. A harmonic unison consists of two notes occupying the same line or space while both notes are played simultaneously. A melodic unison consists of two notes occupying the same line or space, but the two notes are played one after the other. We count the line or space upon which each note occurs as one. When one note occupies a line or a space, and a second note occupies the subsequent space or line above it, the interval is called a second. The bottom note is labeled as 1, and we count upward one line or space, which is then labeled 2. To count the interval of a third, we begin at the bottom note labeled 1 and count upward to the line or space labeled 3. The interval of a fourth is constructed by beginning at the bottom note labeled 1 and counting upward to the line or space labeled 4. The construction of a fifth begins at the bottom note labeled 1 and continues upward to the line or space labeled 5. The same procedure applies when constructing sixths, sevenths, and intervals of 8 lines and spaces called octaves. We use the symbol 8VE for an octave. We may continue this pattern to construct ninths, tenths, elevenths, twelfths without end. With regard to the tonal quality of an interval, we are actually concerned with the number of pitch changes that occur between the two notes. These pitch changes involve combinations of whole steps and half steps. We can change the quality of an interval by altering these combinations. Let's examine the qualities of the various intervals as they occur naturally or diatonically. Then we can modify them using accidentals, sharps or flats, to alter their qualities. These are the distances and qualities of diatonic intervals found in every major scale, regardless of its key signature. Note that the diatonic interval qualities in any major scale are made up exclusively of perfect intervals and major intervals. If one memorizes this pattern, perfect unison, major second, major third, perfect fourth, perfect fifth, major sixth, major seventh, and perfect octave, then one should have little difficulty in modifying these intervals to other qualities, such as minor, augmented, and diminished. We'll begin with the interval of a second in the key of C major, using C natural and D natural, which occurs diatonically between scale degree 1 and scale degree 2. The tone generated by these two notes is that of a whole step. We count the number of pitch changes between the two notes by half steps, because the half step is the smallest change in pitch that we can distinguish, and is therefore the smallest common denominator. We easily determine that there are two half steps between C natural and D natural. Thus, C natural to C sharp equals one half step, while C sharp to D natural equals another half step. Two half steps, of course, make one whole step. Any time we have the written interval of a second separated by the sound of a whole step, it will be called a major second. Using a C natural and an E natural, we'll construct the interval of a third as it occurs diatonically in the key of C major. The number of pitch changes between these two notes equals two whole steps, i.e. from C natural to D natural, continuing through D natural to E natural. Anytime we have a written interval of a third separated by a pitch distance of two whole steps, it will be called a major third. Putting together a C natural and an F natural, we construct the interval of a fourth as it occurs diatonically in the key of C major. The pitch distance between these two notes is 2 1/2 steps. C natural to D natural to E natural, and E natural to F natural. Any time that we have the written interval of a fourth separated by a pitch distance of 2 1/2 steps, we will use the term perfect fourth. Listen again to the sound of the perfect fourth. It is quite a different quality from major. Some might describe it as a thin sound. Others might describe it as a hollow sound. The unison, which has been left out of this discussion so far, is considered to have this same quality, and is therefore called a perfect unison. Playing a C natural followed by a G natural gives us the interval of a fifth. In the key of C major, the pitch distance between these two notes is 3 1/2 steps. One way to count them is C to D, D to E, E to F sharp, equaling 3 whole steps, and F sharp to G natural, giving us the final half step. Anytime we have the written interval, the fifth, separated by a pitch distance of 3 1/2 steps, we use the term perfect fifth. The perfect fifth has, roughly, the same thin or hollow quality exhibited by the other perfect intervals. Playing a C natural followed by an A natural gives us the interval of a sixth. In the key of C major, the diatonic pitch distance between the two notes is 4 1/2 steps. C to D, D to E, E to F sharp to G sharp, and G sharp to A. When we have a written interval of a sixth, separated by the pitch distance of 4 1/2 steps, we term the interval a major sixth. We can use a C natural and a B natural to construct, in the key of C major, the diatonic interval of a seventh. The pitch distance between the two notes of this seventh equals 5 1/2 steps. C to D, D to E, E to F sharp to G sharp to A sharp, and A sharp to B. When the written interval of a seventh is separated by a pitch distance of 5 1/2 steps, we call it a major seventh. Although this interval is quite dissonant, it occurs diatonically within the key, and its quality, therefore, is considered to be major. Finally, we can use a C natural and the subsequent higher C natural to construct the interval of an octave. The pitch distance occurring between the two notes of any octave equals 6 whole steps. In this instance, we'll count it as C to D, D to E, E to F, which is a half step, F to G, G to A to B, and B to C, another half step. All octaves are perfect octaves. Now, let's see what happens to the tone qualities when we modify the number of whole and half steps between these diatonic intervals. We can modify the sound of a major second by reducing the whole step to a half step by lowering the D natural to a D flat, as in the upper illustration, or by raising the C natural to a C sharp, as in the lower illustration. Once again, the interval is written as a second, but this time is separated only by a half step. Anytime we have a written second separated by the sound of a half step, we call the interval a minor second. An additional standard that we can now apply to the naming of intervals is that any major interval becomes a minor interval when it is reduced by 1/2 step in any way. Again, if we reduce the pitch distance of any major interval by 1/2 step, we modify it to a minor interval. Thus, in the case of our diatonic major third, normally C to E natural, by lowering the E natural to an E flat, as in the upper illustration, or by raising the C natural to a C sharp, as in the lower illustration, the pitch distance is reduced to 1 1/2 steps, producing a minor third. Major and minor thirds are often described as having a pleasant consonant sound. When we decrease the pitch distance between the notes of a diatonic major sixth by 1/2 step, it becomes a minor sixth. In this case, we can decrease the pitch distance of our major sixth 1/2 step by lowering the A natural to an A flat, as in the upper illustration, or by raising the C natural to a C sharp, as in the lower illustration. Thus, in this case, a major sixth having a pitch distance of 4 1/2 steps becomes a minor sixth having a pitch distance of 4 whole steps. Like major and minor thirds, major and minor sixths are described as having a pleasant consonant sound. We can change our diatonic major seventh to a minor seventh by decreasing the pitch distance between the notes from 5 1/2 steps to 5 whole steps, by lowering our B natural to a B flat, as in the upper illustration, or by raising our C natural to a C sharp, as in the lower illustration. We'll talk a little now about what happens with diatonic perfect intervals when we reduce their number of pitch changes by 1/2 step. If we lower any perfect interval by 1/2 step, we get what is called a diminished interval. The unison is considered a perfect interval, but diminished unisons are strictly theoretical and do not occur in real music. In order to understand why this is the case, we'll have to talk first about enharmonic equivalents. Enharmonic equivalents are notes that are written differently but sound the same. For example, a C sharp and a D flat, or a C flat and a B natural, as in the upper illustration. Intervals can be enharmonic equivalents as well, such as a diminished unison, a C and a C sharp, or a C flat and a C, and a minor second, a C and a D flat, or a B and a C, as in the lower illustration. Enharmonic equivalents, because they are confusing to read, are rarely used, and then only when necessary to establish the context of a note within a key. You will rarely, if ever, for example, see a diminished unison. 99.9% of the time, it will be written as a minor second. Like the diminished unisons, diminished fourths rarely, if ever, occur. A diminished fourth is enharmonically equivalent to a major third, and that's how you'll find them written. As shown here, we can decrease the pitch distance of the perfect fifth 1/2 step by lowering the G natural to a G flat, as in the upper illustration, or by raising the C natural to a C sharp, as in the lower illustration. When we decrease the pitch distance of any perfect interval by 1/2 step, it becomes a diminished interval. In this case, a diminished fifth. Unlike the other diminished perfects, however, the diminished fifth does not become an enharmonic major interval. This is due to the fact that unlike the other perfect intervals, the diatonic interval below it is also a perfect interval. Thus, the diminished fifth emits its own unique sound and quality. This interval is quite dissonant and so difficult to sight-sing that the early church composers named it the devil's tone. Look at the specific pitch distance between the two notes of a diminished fifth. 3 whole steps, since the G flat is equivalent to an F sharp, or what is called a tritone. As with diminished unisons and diminished fourths, diminished octaves almost never occur in real music. The diminished octave is enharmonically equivalent to a major seventh, and a major seventh is what you will see. We can also modify the sound of a major second by raising the D natural to a D sharp, as in the upper illustration, or by lowering the C natural to a C flat, as in the lower illustration. Observe that the interval is still written as a second, but is now separated by a total pitch change of 1 1/2 steps, which is enharmonically equivalent to a minor third. Anytime we increase a major second by 1/2 step, we call it an augmented second. Indeed, any major interval becomes an augmented interval when it is increased by 1/2 step. We modify the sound of a major third by raising the E natural to an E sharp, as in the upper illustration, or by lowering the C natural to a C flat, as in the lower illustration. Although the interval is written as a third, it is now separated by a pitch change of 2 whole steps, which is enharmonically equivalent to a perfect fourth. We can, of course, increase the pitch distance of our perfect fourth 1/2 step by raising the F natural to an F sharp, as in the upper illustration, or by lowering the C natural to a C flat, as in the lower illustration. Like the major intervals, any time we increase the pitch distance of any perfect interval by 1/2 step, it becomes an augmented interval. The augmented fourth is enharmonically equivalent to the diminished fifth, and therefore has the same distinctive and dissonant sound. The augmented fourth is also called a tritone because, like the diminished fifth, it is made up of a total pitch distance of 3 whole steps. Since it displays the same sound as a diminished fifth, the early church composers referred to this interval as the devil's tone as well. If we increase the pitch distance of a perfect fifth by 1/2 step by raising the G to a G sharp, as in the upper illustration, or by lowering the C natural to a C flat, as in the lower illustration, it becomes an augmented fifth. An augmented fifth is enharmonically equivalent to a minor sixth, both of which are separated by 4 whole steps. Increasing the pitch distance of a major sixth by 1/2 step by raising the A to an A sharp, as in the upper illustration, or by lowering the C natural to a C flat, as in the lower illustration, gives us an augmented sixth. Any augmented sixth is enharmonically equivalent to a minor seventh. Both have a pitch distance of 5 whole steps. When we increase the pitch distance of a major seventh by 1/2 step by raising the B natural to a B sharp, as in the upper illustration, or by lowering the C natural to a C flat, as in the lower illustration, we create the interval of an augmented seventh. Augmented sevenths are enharmonically equivalent to perfect octaves, both having pitch distances of 6 whole steps. This concludes Part 1 of our Introduction to Intervals. In Part 2, we will practice the construction of various random intervals, and we will learn an additional, hopefully faster method of construction using our knowledge of key signatures.